Then we have osmosis, and osmosis should be familiar to us, the idea of diffusion of water specifically. We're moving it across a semi-permeable membrane or a selectively permeable membrane. And keep in mind that osmosis is based on the water concentration. So you're moving from high water concentration to low water concentration. Or really, I tend to try to focus on this one, the idea that movement is opposite for the solute concentration. And I believe last year I told you that the movement was to dilute, that the water moves in a direction to dilute the solute, right? To dilute the more concentrated area and kind of even out. So the idea that in this picture, right, we have two different images, and what you probably can't really tell is that this side is a high solute concentration, whilst here we have a low solute concentration, or at least lower. So as a result, right, the water molecules are actually going to be moving. Notice that we had 1, 2, 3, 4 protein molecules, and we still have 1, 2, 3, 4 protein molecules versus the 8 and 8. So it's not the actual solute that's moving in this case, it's the water that's moving to kind of even things out. Then we can talk about osmotic pressure, which you guys should be pretty good about, talking about the idea of the pressure that moves a volume of water, or we're really talking about the concentration of solutes that causes the movement of water. Water movement will increase as the concentration of solute increases. And really, this might sound a little strange to you guys, but it'll make a lot more sense in 1 second. And what we're referring to is the idea of solutions, right? We talked all the time last year about isotonic solutions, hypertonic solutions, hypotonic solutions. Iso, we should know, is same concentration, hyper, high concentration, and hypo, low concentration. So we should know that in an isotonic solution, we're talking about two solutions with the same osmotic pressure or with the same concentration. And in a hypertonic solution, it's a higher osmotic pressure, a higher concentration, and so on and so forth. And we should know exactly what happens when we look at hyper, hypo, and isotonic solutions. So in this case, we're looking at red blood cells. And that right there is the normal concavity of a red blood cell. This would be a red blood cell in an isotonic solution. Whereas here, the red blood cell seems a bit shriveled. And we should know that shriveling occurs in a hypertonic solution. Just try to keep in mind, the saltier something is, so like hypertonic, really concentrated in salt, the more shriveled up it becomes. It dries you out, right? And that's because the water moves out of the cell. While in this case, the cell appears to be bloated or swollen, and this is a hypotonic solution. So we're talking about water in, water out, water in and out at the same rate. Then we can talk about filtration, right? And filtration is all about hydrostatic pressure. And I want to revisit hydrostatic pressure. I know we talked briefly about it in the very first chapter, but hydrostatic pressure, what we're talking about is the pressure of a fluid due to gravity. Right? So we're talking about how much pressure a fluid exerts and because of gravity. The idea that When you're in a swimming pool and you just kind of dunk your head under, there's not a whole lot of pressure that you feel. But if you dive to the bottom of a 9-foot deep swimming pool down in the deep end, you feel quite a substantial amount of pressure, and that's because of hydrostatic pressure, the pressure that that water is exerting on you due to the weight of gravity and what the gravity force projects on the fluid. So this is just an idea, like a picture of filtering, the idea that you have your water and your solids and your filtration paper, and that gravity is pushing down, which makes the water move through the solids and filter down into the beaker below. So our example being the idea that tissue fluids are forced through the walls of capillaries, right? We have blood pressure that's kind of forcing everything in this general direction. And as everything is being forced, we have some of our smaller molecules that are actually escaping into the surrounding tissue fluid, all right, and kind of into that interstitial space, that space in between. And that's really just a filtration process, the idea that it's because of that pressure, that force that's being exerted, that a little bit gets squished out in the process.